design thinking based case study discussion on vibration reduction in Boeing 787 Dreamliner. So vibration is one of the major problem in aircraft industry, especially in Boeing 787. So we'll use a design thinking approach of all 5 stages, and we are trying to reduce the vibration, and so that we can improve the customer satisfaction and safety and other things which are connected with vibration on aircraft. That will do discussion on this class. Okay.
So in the Empathize case, aerospace engineers focus on understanding the real-time problem experienced by the passenger, pilots and the maintenance team due to the aircraft vibration. So earlier commercial aircraft produced the vibration while takeoff, landing and turbulence and the engine operation. This causes discomfort for the passengers and the maintenance during the long duration flight. So continuous vibration may increase the structural fatigue and the maintenance requirements. So engineer collected the passenger feedbacks and the maintenance report, pilot observation and the vibration sensors reports. This understands the vibrations are more severe inside the aircraft cabin and the structural systems. So in Boeing 787 Dreamliner, the engineer identified the reduction in the cabin vibration was essential not for the passenger comfort and also for improving the aircraft structural stability and the reliability. So this helped the designers to help clearly understand the human-centered problem associated with the aircraft vibration.
So in Empathize, we have clearly understood that vibration is creating all the operation of the flight. The possible things in the vibration in fuselage help us to reduce the inside the passenger comfortable. So that is how the empathy has done with all the feedbacks from engineers, passengers, pilots, and all the other people who are involved in the Boeing 787 design. So let's start with the stage.
In the defined stage, the engineers collected the observable problems into specific engineering problems. The main challenge was to reduce the vibration from the engine, aerodynamic airflow and turbulence into the passenger cabin and aircraft fuselage. Engineers also need to reduce the vibration-induced fatigue in aircraft components while maintaining the lightweight structure. Since the Boeing 787 Dreamliner was designed using advanced composite materials, engineers had to carefully study how the vibration behaved in the composite fuselage structures compared to conventional aluminum alloys. Other important challenge was maintaining the fuel efficiency while integrating the vibration damping technologies. By clearly defining these engineering problems, Boeing engineers established design observation focused on passenger comfort, structural integrity and reduced maintenance and improved aerodynamic performance.
For next stage?
Ideate stage. Aerospace engineer generated multiple innovative solutions for vibration reduction. One of the major idea is to use carbon fiber reinforced composite materials, which naturally provide a better damping characteristic compared to the traditional aluminum structures that are used in aircraft. Engineers also designed advanced flexible engine mount system to isolate engine from the wing system to get better vibration damping. Another important idea was to use vibration damping materials and acoustic insulation system throughout the cabin structure. Aerodynamic optimization techniques are also introduced to reduce turbulence-induced vibration during flight. Engineers studied computational fluid dynamics and structural vibration simulation to identify areas experience high vibration in the system. When the wings were mostly getting the most vibration and passing to the cabin crew. Smart sensor systems were proposed to continuously monitor vibration behavior during aircraft operation. These innovative ideas helped Boeing to create quieter and smoother aircraft cabin environment.
Next stage?
The next one is the prototype stage. In this, Boeing engineers developed structural prototypes and experimental models to study vibration behavior in real operating conditions. Composite fuselage sections, engine mounting systems, and vibration isolation components were tested extensively in laboratories and internal facilities. advanced sensors were installed throughout the aircraft structure to measure the vibration levels during the simulated flight conditions. In the test stage, engineers performed a ground vibration test, structural fatigue analysis, and a real flight testing to evaluate the effectiveness of vibration reduction technologies. Passenger feedback and the flight performance data were continuously analyzed to improve the final result. The results showed that the Boeing 787 Dreamliner achieved significantly lower vibration levels compared to the previous generation aircraft. These improvements enhanced the passenger comfort, reduced the maintenance requirements, increased the structural life, and improved the overall aircraft performance.
So, finally, with this discussion, we observed that the Boeing 787 Dreamliner, they are mostly the components are made up of, structural components are made up of composite material. The composite material, the damping ratio is very low. So, damping ratio is comparatively high compared to the natural materials like aluminum and other alloys. So, there we can reduce the vibration or the absorption. And also the engine mounting system isolator were used. So we have seen in the class absorber and isolator. Isolator is better than the absorber, like prevention is better than the cure. So how these engine are producing more vibration, this isolator will reduce the vibration to transmitting the vibration from engine to the fuselage. And also they are using the acoustic barrier insulators so that the noise and vibration will reduce to the inside the cabin. So that is how the Boeing 787 have done the several iteration by getting feedback from the engineers as well as the passengers, and also they place several sensors to measure continuous vibration during runway, takeoff, ride share and landing, and other cruise condition. With that data, they are identifying where the structural vibration that is producing fatigue as well as the aerodynamic phenomena that is due to the fluid effect. So vortex generating fluid structure interaction also produce the induced vibration that will also causes the vibration. So they have the aerodynamic performance improved also made the aircraft in reduction in vibration. That is how they have done, and they have achieved partially also, and still they are doing the reduction of vibration on the fuselage and also other components. Usually in landing time they will feel more vibration, more jet. So these are in future flight they will try to reduce by studying materials, aerodynamics, and also the advanced the composites. So this is how the design thinking approach help us to understand how this Boeing 787 Dreamliner have achieved the vibration reduction on their aircraft. Okay, so we will discuss on next topic and next class. Thank you.
Thank you.